How's it going? As you can see, we've got this game. It's looking pretty good, but let's go ahead and add some textures. If you look here, you'll see that we've got in the repo a bunch of textures that we're going to put in here. So let's go in and define their file names to start with. As you can see here, I'm using the region and end region tags to create collapsible regions. Sort of just makes it a little neater. I'll go ahead and do that for the functions as well. Now let's write a helper function to load a texture. Okay, now a little bit of refactoring. We're going to go to the renderer and load in all of those textures. Then we're going to pass the textures to the game renderer, which passes them along to the ray trace function. Now let's go ahead and make a function to draw a textured vertical line. The purpose of this function is not to be accurately rendering, but rather just to test that the textures were loaded in, that the images are all working. Okay, so as you can see here, I'm sort of faking out a little bit with the texture coordinates. I am using the pixel coordinate on the screen as the texture coordinate. This is just to check that the images were loaded in and everything's functional. We can then go down to the ray trace scene function and adapt it so that we're calling this vertical line texture function, but only for the wall segment, not for the ceiling and floor. Oh, something I missed as well. While I remember, when we trace, up here we're doing this check with the side and we're incrementing the color. I'm actually not going to do that anymore. I'm just going to keep the raw numbers as they are. And I'm not going to offset. I'm going to actually, reduce the index by 1 because a value of 0 on the map indicates empty space. But in my texture array, I still want to be able to use element 0. So I want to change it from a 1-based index to a 0-based index. You would be surprised the number of errors which are just off by 1 errors. Anyway, where was I? I want to fetch the appropriate texture. And then use that texture to draw. Okay, so we can verify that the textures have been loaded in. This is pretty funky. It's actually pretty, you could make a game just like this. How cool is that? I'd play this game, but yeah. Let's actually fix it now. So interestingly, we've got the images in, they're loaded. Now where we go from here is it decomposes into 2 almost independent bits. We need to get the texture X coordinate and the texture Y coordinate. Consider a top-down view of the world. We can visualize a wall segment as either running along the X or Y axis. The X texture coordinate tracks how far a ray's intersection point is from the wall segment's origin. If the ray took a horizontal step to hit a wall segment, then it hit a vertical wall segment, and the texture X coordinate is given by the Y coordinate of the hit. Similarly, if the ray took a vertical step to hit a wall, then it hit a horizontal wall segment, and the texture X coordinate is given by the X coordinate of the hit. Let's go ahead and adjust the trace function so that it returns the side variable, and then we'll use that information to get the texture X coordinate. Then we'll go ahead and adjust the textured line function appropriately. Okay, so hopefully we can see that the X coordinate at least is sort of anchored. Now, this will be a little hard to explain, it's very subtle, but we may have situations where opposite walls are mirrored in a weird way. So we can sort of correct for this by reversing, this is so trippy, we can correct for this by reversing the X coordinates under some circumstances. And this will be a little hard to see because currently the big issue is the texture Y coordinate, but it's doing something. It's doing something. We'll leave that for now. Right, so the issue is texture Y coordinates. Currently, we're stepping down 1 pixel at a time along a vertical line, choosing a pixel from the texture and drawing it on the screen. But there's a problem. In reality, a texture could either be squashed or stretched. A wall segment actually has 2 heights, the original intended height and the height on the screen. We need to work out how far to step down the texture for every pixel we step down on the screen. So here I'm just reusing that wall height variable that I calculated in a previous video. And remember that the wall height is really like half of the wall height. It's the deviation of the wall away from the center line of the screen. So up here, I'm sort of taking that texture height and I'm finding the scale factor. I'm dividing it by the full height of the wall. And this V variable is tracking the pixel on the texture, the Y coordinate on the texture, which can be in fractional form, which is why I'm rounding it. But yeah, let's go ahead and look at this. Okay, so this looks pretty good. There's just one issue, and we can see this here on our right, okay? So if we go and we draw a segment, but then the wall segment is clipped by the screen, then of course the Y coordinate is clipped, but the texture automatically is starting from where that clipped point is. So what we need to do is we need to work out how many pixels, if any, have been clipped from a wall segment and account for that clipping amount. It's actually surprisingly straightforward. We basically want to work out the theoretical height of the wall and then compare. Okay, so here's what we've got. Remember that the walls are measured sort of relative to the center of the screen, which is why I've got this half screen height. Now, if clipping has occurred, then the wall top value would be negative because we'd be going above the top of the screen. So if we take the negation of that, that will be, this value here will become positive if some pixels were clipped. Otherwise, the clipping will come out to 0. And then if we take that clipping amount, that's the number of pixels which were done, we step down the texture by that many pixels before we start drawing. So anyway, get the suspense out of the way. We've got this, and now we have not got that weird clipping effect, and everything is good. So yeah. There we have it. It's actually starting to look pretty cool, and I even don't mind this. This looks okay. This all looks okay. Oh, here we go. Some of this weird. It's a little hard to see, but some of this weird texture mapping on the left, I'm okay with that. Looks sort of retro, but yeah. There we have it. So I will leave that there, and yeah, hope you had fun. Wish you all the best, and I will see you again soon. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe, let me know what you'd like to see, let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Karet, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.